All right, well, we're moving on in our class outline. We're still in this first section, making arguments for the existence of God. Last week we talked about the design argument. I'll zoom in here to the section that we're on right now. So last week we talked about the design argument for God's existence, and if you remember, we looked at three versions of it: the design of the universe, the design of Earth or our solar system, and then design that we find in life itself, like DNA and for example. And it seems like there is design in those things, so it begs the question, where did that design come from? And we've just made the empirical observation, we as the human race, that we've never seen design come from anything else but an intelligent mind. So I think it's a very strong argument for the existence of God. And as we mentioned, it's even among atheists, what's found to be the most compelling, strongest argument for God's existence. However, there is a common objection to the design argument, and in particular, the design of life argument for God. And of course, that is evolution. So some people claim that evolution has completely defeated at least the design argument for life. So that's why we want to take a whole week and look at this issue of evolution. So one of those folks that claim that evolution has defeated the design argument from life is Richard Dawkins, one of the world's most famous atheists. He is a scientist at Oxford, and he agrees that life appears to be designed. He affirms that. However, he argues that evolution provides an explanation for that appearance of design. So he's one of the most outspoken critics of the design argument. For example, he has said that Darwin has provided an answer to William Paley's watch example. One of Dawkins' books is called The Blind Watchmaker. That evolution is a blind watchmaker in the sense that it developed the watch, from Paley's example, finding a watch on the ground and assuming, without a doubt, that somebody designed it. Well, Dawkins says nature is like a blind watchmaker. It created a watch, life, but there's no intelligence behind it. So, we want to take a look at this objection to the design of life argument, and here's how I'm going to do it. I'm going to lay out my entire case, and then we're going to go through it step by step. So we need to ask this question: does evolution prove that there is no God? And I think the first step in my argument, my case for answering this no, is, of course, if evolution is false, then obviously it doesn't prove that there is no God, right? So if evolution is false, then it doesn't defeat the design argument. It doesn't prove that there is no God. To that end, I'm going to present tonight what I believe to be the strongest argument against evolution. There's a lot of people who argue against evolution, but I think at least this argument is the one that I've found to be the most compelling argument against evolution. So I'm going to present that for you tonight. But then the second step of my argument goes like this. Even if evolution is true, it still doesn't prove that there is no God. Now this might be interesting to some of you who have been maybe grown up or who have thought that evolution and Christianity are mutually exclusive, that both can't be true, it's got to be one or the other. And I'm going to make the case that's just not true. So we'll do that towards the end. The bulk of this evening, though, I'll spend presenting what I find to be the strongest argument against evolution. Now, we need to start out with the basics. There's a lot of folks who maybe have heard about evolution, but they haven't, they don't have a great understanding of it. So I apologize if you already understand evolution, the theory of evolution. This might be very rudimentary for you, but I need to start out kind of at ground zero for folks who don't have a good understanding of it. So we're just going to cover the basics of evolution. There's three main tenets, if you will, three main aspects of the theory of evolution. The first one is that all of life, whether it's insects, human beings, bacteria, etc., all of life can be traced back to a common ancestor. That's one of the key aspects or key parts of the theory of evolution. The second key aspect is that organisms have offspring, they reproduce, and that these offspring have different traits, different characteristics. Like I have 4 children and they're all a bit different, not only in personality, but in physical things as well. They're just different. So that's a key aspect of evolution that we'll dive down into more. And then the third aspect of it is that natural selection determines which of these different traits or variations among the offspring get passed on to the next generation. So natural selection is a key aspect of evolution that we'll have to unwrap with a little bit more detail. Let's start though with trait variation. The fact that when organism, any type of life, reproduces, there are differences in the offspring of that organism. So for example, just take, something that we're all familiar with, cats and dogs. When a dog has a litter of puppies, all the puppies are a bit different from one another. Now, people have been making use of this fact for thousands of years, right? Human beings have been utilizing this trait variation for a long time. What I'm talking about are breeders. So breeders, human beings, have been artificially selecting, right? What do I mean by that? Well, breeders have selected of the offspring which ones have traits that they would prefer for whatever reason, and then allow them to mate with each other so that they would pass on those particular traits that they're trying to develop. So breeders have been using this for thousands of years to breed, for example, faster horses, fatter pigs, so on and so forth. So that's artificial selection, where an intelligent mind, if you will, human being, is doing the selecting of which offspring get to pass on their genes to the next generation. And human breeders have had a lot of success with that. Charles Darwin's brilliant observation was that nature itself was doing the selecting. And this is something that we can celebrate about Charles Darwin, that he recognized, him and others, he was the first to publish his ideas scientifically, but other people were coming to this conclusion as well during the same time, middle of the 1800s, early 1800s, that nature was doing this, a similar sort of selection process. Now we want to be careful here. We don't want to personalize nature. It's not as though we're talking about Mother Nature, or that nature has some sort of a consciousness that is deciding, like a breeder, who gets to pass on their genes and who doesn't. No, when we say natural selection, we're mostly talking about a particular environment that an organism finds themselves in. So when we say nature or natural selection, we're talking about a particular environment. And usually, environments are going to be harsh environments. And so it's the process of selection then is simply that organisms or offspring that don't have traits conducive to that particular nature or conducive to that particular harsh environment are less likely to survive and therefore mate and therefore pass on their genes to the next generation. So it's that nature or these harsh environments are selecting which traits to pass on. And it's the traits that are more suited for that particular environment that organism is in. That's why this process is also sometimes referred to as survival of the fittest. Not physical fit. When you think of fittest, sometimes we think of people that are really in good shape. They're physically fit. We're not talking about that sort of fittedness. We're talking about those that are well suited for the particular environment that they're in. And I'll give you some examples here, some simple examples. Those that aren't fit or suited well for that particular harsh environment they're in don't survive, therefore don't mate, therefore don't pass on their traits to the next generation. In effect, what Charles Darwin and others recognized is that this process of natural selection accomplishes the same thing, in a sense, that breeders, human breeders, have been accomplishing for thousands of years. That it actually, the organism changes in response to this selecting process, this natural selection, this weeding out of those with unfit traits, traits not well suited for that particular environment. So let's just take another simple example. Let's go back to the dogs with puppies again. As I keep saying, fittedness depends on the environment that they're in. So in a cold environment, if a dog has puppies, again, just to make it super simple, if a dog has puppies in a cold environment, well, those with long fur are going to be more fit. They're going to be more well suited for that cold environment. Therefore, more likely to survive, more likely to mate and pass on their genes to the next generation. In a different environment, let's say a warm environment, those with shorter fur are more fit or well suited for that environment. So if we just stick in a warm environment for a while, only those then that survive in their particular warm environment will have more puppies, and then that same thing happens over and over and over again, multiple generations, such that, you know, those with short fur are more likely to have puppies with short fur, and so puppies with long fur just become less common and less common and less common, and before you know it, after multiple generations in a warmer climate, the short fur becomes the dominant trait. And then all puppies in that particular climate have short fur. We can ask the question when we stand back and we see this, and this is, you know, all proven, and we can observe this within, you know, even just a few lifetimes of scientific observation, we can see this process play out. The question to ask is, how powerful is this process? How far can this process take a particular organism? Now, it seems like it's a pretty powerful process. I mean, just think about it for dogs for a moment. Within this process has created a radically different organisms from a common ancestor. I mean, everything from a Great Dane or a Saint Bernard down to a little Chihuahua. I mean, if we didn't know any better, who would ever guess that a Chihuahua and a Saint Bernard come from the same ancestor? They seem radically different animals, right? So that just goes to show the power of this process, that it can produce radically different animals, radically different organisms. The question becomes, though, is it powerful enough to create or produce a completely new type of organism? Another way to ask this question is there a limit or an edge to this process that it can't go beyond? Is there a limit to this evolutionary process? Is there an edge? And one scientist has, I think, made a very compelling case that in fact there is. There's a limit. There's an edge to evolution. So the scientist I'm referring to, and we're going to focus on his work tonight, is Dr. Michael Behe. Let me give you just a little bit of background on him. So he got his PhD in biochemistry at the University of Pennsylvania. He did postdoctoral work on DNA structure at the National Institutes of Health. Currently, he's a professor of biochemistry at Lehigh University. Now, just so you're aware of what his position is, he affirms one of the key aspects of evolution, that all life has descended from a common ancestor. So as I said, all dogs, all humans, all bacteria, all insects, he would affirm that all forms of life we see today can be traced back to a common ancestor. So he affirms that part of evolution. However, based on his scientific study, he has come to reject that natural selection is able to produce an entirely new species. As powerful as trait variation and natural selection is in creating vastly different types of dogs, it's not powerful enough to create a brand new species. And that's hence the name of his book, The Edge, or The Limit of Evolution. And I think in this particular book, he's written several books against evolution, but I think this one I found to be the strongest argument that I've come across so far that evolution is false. Now, it's important to note I'm not arguing against every aspect of evolution. I'm not saying all of evolution is false. This conversation can get really confusing because different people mean different things when they use the term evolution. And I'll splice it out and make some key distinctions here in a few minutes. But it's important to note that I'm not denying everything in the theory of evolution. For example, the stuff we've talked about so far with dogs and other organisms, all animals having offspring with different traits, and then nature selecting what traits are best suited for that particular harsh environment and passing them on, resulting in radically different organisms, the two different dogs. Everybody agrees, and affirms that aspect of evolution. The controversy comes when people, including Charles Darwin, propose that this process can create new species. That's where the controversy comes. So Darwin, says it in the title of his book, On the Origin of Species. His theory that he proposed was that this evolutionary process we've been talking about, which I affirm thus far, is powerful enough, given enough time, that not only will it change a dog into a completely different type of dog, but it'll create, given enough time, a completely new and different species. And in fact, according to his theory, that's where all of our variated species came from, a common ancestor. Through this process, now we have all these different species that have been produced by this evolutionary process. This is the part that's controversial. This is the part that Behe is arguing against. So I'm going to do something a little bit different tonight. And this is, it's more for the people here in the room that are coming to the class here. But for those watching online, I think this would also can be helpful for you as well. What we're going to do is just have a few discussion breaks. So it breaks up having to listen to me for so long, and then it allows those who are taking it here in person to discuss and think about the material that I've presented thus far. So I'm going to propose this discussion question for the class here to chat about, and you might just want to, we'll skip this in the video that we put online, but you might just want to pause it as I put this question up there and think about it on your own for a few minutes. Well, we had a good time discussing this question here in class. Hopefully you've had some time or you paused it to think about this. So was it reasonable for Darwin, based on the small-scale evolution that he observed scientifically, was it reasonable for him, based on that, to propose this hypothesis? His hypothesis, again, his theory being that this process eventually could produce new species, large-scale evolution. And I think it's a reasonable hypothesis. I think based on what he knew at the time, it was very reasonable for him to think this. I mean, we often make this extrapolation, don't we, in science and in other fields. When we see something happen on a small scale, we theorize at least that possibly this is also taking place on a larger scale. I mean, there's a sense in which that's exactly what Isaac Newton did, right? So when he, legendary, experienced, the apple falling from the tree, gravity on a small scale, he theorized at least that possibly it's that same force that affects things on a larger scale in the solar system with planets and stars, etc. So Darwin, in a sense, did something similar, right? He observed evolution taking place on a smaller scale, famously with the beaks of the birds, the finches that he studied, right? And then he speculated that possibly, on a small scale, if this process was able to affect the size of birds' beaks, possibly if given enough time, it could radically change these birds, or had radically changed all species and created new species if this process had enough time to play out. Now, the distinction that I'm drawing, I keep talking about a small scale and a large scale. In more technical terms, this is referred to as micro and macroevolution. So microevolution is usually referred to as the change within a species, like we've talked about the radically different dogs that have been produced both by artificial selection and natural selection. And then macroevolution would be a large scale where the theory at least says that new species have been developed through this process. Now, some people will balk at these terms and they claim that Christians or people who are against evolution made up these terms of micro and macroevolution. But that's just not true at all. In fact, I'm going to give you some examples of evolutionary scientists who affirm evolution using these terms. So, for example, in 1940, a Berkeley geneticist, Richard Goldschmidt, he published a book arguing that the facts of microevolution do not suffice for an understanding of macroevolution. He concluded, microevolution does not lead beyond the confines of the species and the typical products of microevolution. The geographic races are not incipient species. More recent example, 2001, biologist Sean Carroll wrote in Nature, can't get much more prestigious than that scientifically. He wrote this: a long-standing issue in evolutionary biology is whether the processes observable in extant populations and species, microevolution, those are his terms he's using, are sufficient to account for the larger scale changes evident over longer periods of life's history, i.e. macroevolution. So it's just not the case that only Christians or only those that are against evolution or don't believe in evolution have invented and used these terms. These are scientists themselves who affirm evolution using these terms. Well, since Darwin's day, since the mid-1800s when he proposed this theory, have we learned things about the process which would indicate there's a limit to what it can do? In other words, is there an edge to evolution? Scientist Michael Behe says yes. Now, one of the key aspects, as we've talked about before, to evolution is this variation among an organism's offspring. Now, this really is the fuel that drives the evolutionary process. I'm going to use that term a lot, fuel, that drives the process. Because without these variations, just think about it for a moment, even artificial breeding, artificial selection wouldn't work unless there were variations in the traits among the offspring an organism has. There has to be changes from parent to offspring for either the breeder, artificially, or nature, naturally, to select. If there's no variation, then the process can't even get off the ground. So Darwin acknowledged this. I don't think this is anything too profound. Unless profitable variations do occur, natural selection can do nothing. So let's focus in on that for a moment. What causes these variations? And this is something that in Darwin's day, scientists really did not understand at all, including Charles Darwin himself. So there's a lot that they didn't know. Let me go through a list here of things that they did not know the answer to when this theory was proposed. They didn't know why there were variations among offspring, whether it's dogs, humans, bacteria. They didn't know why there were variations among the offspring. They didn't know what caused the variations. They didn't know how much these variations could vary. I mean, could a dog someday, or has already, and we just haven't witnessed yet, a cat? Could a cat be born from a dog? Is that possible? We've never seen it, but could it happen? How much variation could there be among offspring? They didn't know at the time, scientifically, how these variations, how these traits got passed from parent to offspring. They didn't know. They knew that it happened, but they didn't know how. They also didn't know if anything new was ever created in these variations, or if they were just different combinations of traits that have already been there or are already in the parent, just a different combination of them. They didn't know the answer to that question. They also didn't know about these variations if they were completely random and accidental. Maybe there were specific causes that were causing these variations to be a certain way. They didn't know the answer to that. And then lastly, in the mid-1800s, they were not aware of if this was enough fuel to allow organisms over time to transform into completely different species. They didn't know the answer to that, and it's one of those things that's difficult to prove because it's a process, if it does happen, takes place over thousands, millions of years, which is very difficult for us as finite beings to observe empirically because we only live maybe 100 years at the most. So the question becomes, have we, within science, since the mid-1800s, have we discovered answers to these questions that would cause us to conclude that this evolutionary process just is not powerful enough to create new species? And again, Behe, the scientist we're focusing in on tonight, says yes, there's a limit, there's an edge to what this process can do. One of the biggest discoveries over the last 100, 150 years in this arena is genes. We've discovered that we're all wearing mom's genes, right? And what I mean by that is what we discovered genes and then DNA, of course, but all of us have inherited genes from not only mom, but from dad as well, right? Genes were discovered in the 1930s. This was 70 years after Darwin published his book. We discovered genes, and we learned that these genes were the basis for these inheritable variations that offspring inherit from their parents. They inherit a random mixture of their parents' genes. So for me, for example, half of my genes came from mom, half of them from dad, But there's variation among them, like me and my siblings. We're not exactly the same because we inherited a different set of genes from our parents. We all got, half of our genetic code. Or let me say it backwards. Let me say it this way. A parent passes on half of their genetic code to each of their offspring, but what they pass on is a different half each time. That's why when you have siblings or different puppies, they vary because it's a different set of genes from each parent, and that's what creates this variety. But again, I guess one of my key points here is that this wasn't discovered until several decades after the theory was proposed. And one of the things that we discovered when we learned about genes was that the genes themselves are not changing. The genes themselves aren't changing when they're passed on from parent to offspring. There's other things that can change the genes potentially. We'll talk about those. But in just the simple normal process of parents passing on their genes to offspring, there's no change in the genes. There's just a reshuffling of the genes that are already there from, both parents in the case of, species with sexual reproduction. And this is why horse breeding, right, can produce very, very different types of horses, not by adding anything new to the gene pool. There's never anything, breeders don't add new material or new information to the gene pool, but horse breeders are just selecting artificially a smaller set of genes from the larger store of genetic material that are already in the gene pool. They just keep more narrowly selecting the genes that they're looking for. With horses, often it's speed or possibly strength for workhorses. Pigs, cows, fatter ones, right? Just keep selecting the genes that they're looking for that are already there in the gene pool. Similarly, natural selection, at least at this level, within a species, isn't creating any new information in the normal process of parents passing on their traits to offspring. It's just a reshuffling of the genes to, in natural selection, bring traits that are well suited for the particular harsh environment that they're in to the surface, which, amazingly enough, allows a species to adapt, change, if you will, to better fit their environment. So it's actually a very remarkable process. But the key is there's nothing new being produced here. It's just a reshuffling of information that's already there in the genetic code, the genetic gene pool, if you will. So Mendel's genetic inheritance gives a much more limited view of evolution than what Darwin proposed. This variation, these traits, discovering this about genes gives a much narrow, almost provides the first limit or edge to evolution. Let me give you a quote by another thinker. This is William Dembski, who's really well known in this area. He wrote that this inheritance, this passing on of genes that Mendel discovered, genetics, genes, this inheritance accounts for breeders producing sweeter corn or fatter cattle through the shuffling of existing genes. At the same time, because of the stability of genes, it also explains the inability of breeders to turn corn into another kind of plant or cattle into another kind of animal. What breeders, through artificial selection, accomplish is diversification within a given species. He wrote elsewhere, large-scale evolutionary change requires wholesale changes in the physical and behavioral characteristics of organisms, the entry of novel, new information, leading to increases in biological complexity, and ultimately the origin of novel, new types of organisms. The passing on of different gene combinations from parent to offspring just does not accomplish this. So after this discovery about genes several decades later, passing on genes, so on and so forth. Something else then was proposed that might explain how this large-scale or macroevolution could be possible. And of course, what I'm talking about is mutations. So after the discovery of genes and how we learned that normal process of parents passing on their genes to offspring had very distinct limitations to what it could do, only diversification within a species, very limited. Then what was proposed was mutations were the fuel that could possibly drive more macro evolutionary process. The macroevolutionary new species. So they claimed that this was the key ingredient then necessary to go from micro to macro. The normal process, just genes being reshuffled, wasn't enough for macro, so now the new proposal was these mutations. Because there had to be new information from somewhere. The normal process of parents passing on their genes to offspring, we learned, didn't create any new information, just shuffled around the existing information. So they had to come up with a different idea of where this new information came from. You have to have new or novel information, something that's not already there in the gene pool, in order to get a new species to develop. And of course, many scientists today believe that mutations provide this new information. So let's talk about mutations here for a little bit. What are mutations? When an existing gene has an accidental mutation, it's really a mistake. It's something that, if you will, shouldn't have happened. And that's why, it's called a mistake or a mutation. It's a random change that occurs at a molecular level in the DNA. It can be caused by many things. It can be caused by radiation, viruses, chemicals. There can be errors sometimes in the DNA replication process. And sometimes mutations are caused, and we don't know why yet. So there are sometimes mutations happen and we don't know the cause. But from what we can tell, they seem random and arbitrary, or just random mistakes. So the most common are these replication, these copying errors. But even among them, they're very rare. Okay, the copying process of genes and DNA is a very faithful, consistent process. However, there are times where mistakes are made and then you have a mutation, an error in the DNA, so to speak, in the gene. Now, we've studied this, and scientists have studied this, and they can actually calculate, if we take a look at all the times of replication, we can, with probability and statistics, fairly accurately predict how many mutations are going to occur in X amount of copying. So it's a fairly standard or fairly set amount of mistakes that are made. Those have been calculated, the frequencies have been calculated. The key question I think we should ask then is it possible to build some sort of new structure, a new complex structure, let's say like the human eye, through this random accidental process from small step-by-step accidents? Now remember, this is natural selection, not artificial selection. So each of these small little changes or mistakes or mutations have to be useful on its own. For nature to select it or to pick it up and pass it on to the next generation, it has to be useful in and of itself. In other words, nature is a blind process, so it can't look ahead consciously like an artificial breeder. A human breeder could look ahead and have a goal of what they want to see, and then select horses or cows or pigs to make that happen, that have the traits that they're looking for. Nature is blind in the sense it can't look ahead. It can only select the mutations one at a time, if you will, that have to be useful on their own. The question is, through a process like that, can something complex, for example, like the human eye, be built? And this is where Behe's, one of Behe's other books is very useful. Behe did a lot of work on this idea of irreducible complexity, where he argued that complex biological mechanisms, like the human eye, for instance, cannot be built one accidental step at a time. In other words, you need all the pieces there at once for the mechanism, like the eye, to work. It's not something that can be built one accidental mistake at a time. All the pieces have to be there for the mechanism to function. Now, his classic example, this is a famous example that he used, you might be familiar with it, is the Bacterial Flagella. Now, this is rather remarkable because this, in fact, is a minor, a tiny little, literally a motor on the back of certain cells. But they're so complex. Look at all these pieces that have to be there, just like in a real motor that we're used to, a car motor, a boat motor. All the pieces have to be there for it to work. And according to Behe, he made a sound case that something like this cannot be developed one piece at a time, one accidental piece at a time, because you need all the pieces in place for it to even work. And Darwin himself admitted that if it could be demonstrated any complex organ existed which could not possibly have been formed by numerous successive slight changes, my theory would break down. Now, it's important, I've come up with this scenario that I've run past several people, and they would affirm it. But I've come up with this scenario that I think drives home how serious a problem this is, okay? This idea of trying to build something complex with one accident at a time. And I think this hypothetical, this analogy, I guess is the best way to word it, this analogy that I've developed is a lot better analogy than the analogy that some who oppose evolution have thrown out. You might have heard that before. So sometimes people will throw out the analogy of, how could a tornado go through a junkyard and build a car, right? If a tornado came through a junkyard, it wouldn't create something like a car, it would just cause disorder. And they use that kind of an analogy of the theory of evolution to kind of try to point out how absurd or silly the theory of evolution is. And I don't think that's a good analogy. And rightly so. I think evolutionists have pushed back on that analogy and said that doesn't represent our theory well. And I would agree with them. I don't think it does represent evolution. It doesn't represent the theory of evolution well. But I think my analogy does better. And I proposed it to people who believe in evolution, and they would affirm that this analogy I'm going to propose fits better. So it seems to me what the theory of evolution is proposing is similar, analogous to this. It's similar to writing a sentence, nay, a book even, writing an entire book, one letter at a time, where each letter itself has to be useful or has to work, if that makes sense. So randomly, it has to be a random process, of course. Accidentally, what's the next letter? Could be anything A through Z in the English language. And then it can select one that works, but each letter has to work. So you start out with the first one, run through all the letters of the alphabet, and the first letter is going to have to be an A or an I, maybe another, might be another other letter or two, but probably an A or an I, because both of those, letters work on their own, at least as a word. They don't make a sentence, or definitely not a book, but at least you can have a start with an A or an I. Okay, let's say, give them that, start with that. What's the next letter? Well, you run through accidentally. You can't look ahead and think about a sentence you want to write. That would be cheating. It's just going to happen randomly, right? Like the theory of evolution. So you run through all the letters that could, with, let's say it started with an A, so all the letters that could work on its own to then make that word. So a letter like T, AT, at, a letter like B, AB, ab, like an ab muscle. So all the letters that would work, and then if you get one that works, fine, you go on to the next one. And then you cycle through all the letters. I guess you could use a space as the 27th letter, so the 26 letters of the alphabet, and then a space, and you run through the process again, and what would work? A space would work, right? Because then you have ab, or possibly an S would work, because then you have abs, and that's what you would have to do to create not only a sentence, but according to evolution, we've got an entire volumes of encyclopedic information, volumes of encyclopedias in our DNA that have been written out in a language. So the analogy is writing a book that works, right? Every single letter would have to work, and just think through that conceptually. Is that possible for an entire book to be written? A book that has a beginning, a climax, an end, a story arc, characters, heroes, villains, all that has to be in a good book, but you can only write it through that random process. And it's just not possible. So I think that's a better analogy of what the theory of evolution is proposing, and I think it shows how you just can't write a book that way. It's not possible. So let me give the group here that's taking it in person a chance to discuss again. And here's the question I want you guys to discuss. Is this irreducible complexity argument that Behe and others have proposed, is it a good argument against macroevolution? So if you're watching it online, maybe just pause here and take a couple minutes and chat, or think through. If you're with people, chat about it. But if you're by yourself, just take a few minutes and think through this argument and see if you think it's a good one against macroevolution. Okay, as for me, I think this is a strong argument against evolution. I find it compelling, this irreducible complexity. I find it to be, I'm not a scientist, so some of this stuff goes over my head, but I find this to be fairly compelling when I read both cases and when I read Michael Behe and others make this case. But it's kind of ended in a stalemate. There's a sense in which this conversation of irreducible complexity is kind of just ended in a stalemate. I mean, one side, Behe and others say, look, it's impossible to build a complex machine one accidental step at a time. Behe and others just say, it's impossible, you can't do it. The other side says, well, no, we could conceive how it's possible. We can imagine, we could come up with an idea of how it happened. And they propose different ideas and theories. So it kind of ends with this stalemate where one side says, I just can't see how that would even be possible. And the other side says, no, we can see how that might be possible. And so it just ends with that kind of a stalemate. But it's a conceptual stalemate. That's the issue. Neither side can really prove empirically, in a sense, whether it's possible or impossible, because we just haven't been around long enough to be able to witness it ourselves and make, empirical discoveries and see if, this is how things happened. It would be much more impressive if we had some sort of an empirical example, but it takes millions, and according to the theory, millions and millions of generations. It would be nice if we could do that, if we could observe thousands, millions, even billions of generations, then we could see what accidental mutations and natural selection can really do. The good news is there's a sense in which we can and have done this. We actually have several scenarios that we can observe just like that. Behe's next book covers these examples, and this is why I find his book, The Edge of Evolution, His previous books were about irreducible complexity, but this one, The Edge of Evolution, is where he looks at these empirical examples. And I just have found this to be the most powerful argument against evolution. Because what he points out is that we've been able to study what mutations have actually accomplished over trillions of generations. And any scientist can do this study within just a few years. And this empirical study, this empirical science, has shown that there's just not enough fuel there, random mutation with natural selection, there's not enough fuel there to accomplish macroevolution. Now, one of the examples that scientists can look at and have looked at, for example, is fruit flies. This is the classic example, and we can study this process with fruit flies because they have such a short lifespan. So you can watch the process in action. You can speed it up, if you will, and watch multiple generations within just a few years. And we can kind of step in a little bit artificially, and scientists have, and bombard these poor fruit flies with radiation to cause more mutations than normal. And we've done that just so we can study mutations more and see what they can actually do. And through this process, scientists have developed a really good idea of how much random mutation can actually accomplish in building things. So through this process, the scientific process of bombarding these poor fruit flies with radiation, observing the mutations, seeing which ones are beneficial or not, scientists have made trillions of mutations to the genome of fruit flies. And all but just a handful have been irrelevant. These mutations haven't helped the poor fruit flies at all. In fact, the vast majority of them have been extremely detrimental to the fruit fly's ability to survive or reproduce. So the vast majority of mutations, and should be expected, are destructive instead of constructive. So we could ask ourselves, okay, well, what about the mutations that do help? So we've done this process on these poor fruit flies. The mutations that do help, let's focus in on those. Because again, according to the theory of evolution, only the helpful ones would be selected by nature. Well, even the helpful mutations have never created any new information. There's been no evidence of mutations with the poor fruit flies creating, for example, new structures, right? They merely alter, sometimes very grotesquely, merely alter the existing structures that are there, but most often break or misshapen the existing structures. They don't build anything new. These mutations just break things. Now, what we're going to see, though, when we look at the next example, or the next example that Behe provides, is that breaking things, mutations that break things, can actually be helpful sometimes, can make an organism more fit. But the key thing here is that the mutation hasn't built anything new, it's made the organism more fit by breaking things. And we'll see that in the example he used, Behe presented with malaria and sickle-cell anemia. As you know, malaria is a terrible disease, and it's caused by a parasite that's transmitted most often by mosquitoes. So a mosquito bites you in a place where there's malaria, and then you get that parasite. And it's a very serious disease, still is in many places around the world. Over 400,000 people a year die from malaria. But in terms of a scientific perspective, malaria gives us empirical evidence of the power of mutations. It gives us empirical evidence that we can study of how much mutation can drive this evolutionary process. And why is that the case? Well, it's numbers. It's just numbers. Malaria grows to huge, huge population numbers. Numbers that are much, much greater than any mammals, reptiles, or insects that we could study in our own lifetime. So scientists can watch malaria mutate over literally trillions of generations in just a few years. So think about that. We, as scientists, can evaluate trillions of generations in just a few years and watch the process of mutation and natural selection to see what it can do. So instead of just theorizing conceptually about what it could or couldn't do over millions of generations, we can observe it empirically. For example, in this situation. So what I said is by looking at the process of malaria and sickle cell anemia. I need to describe what that is for those who aren't aware. Sickle cell anemia, it's an actual mutation that takes place within humans. It causes those who have this mutation to have red blood cells that are misshapen. They're, instead of nice round red blood cells, they're more in a sickle or like a crescent moon shape. So it's a mutation that some humans have, and it's very damaging to a person's body. It's not good to have this mutation. It's destructive, it's painful. These cells that you can see in this picture, these sickle cells accumulate and then block the blood flow, especially in smaller capillaries in your body, causing tremendous pain. So this mutation, sickle cell anemia, is well known by scientists, and we've studied it, and it's a very harmful mutation. However, those who have it seem to be able to fight off malaria better than normal people. Let me explain how that process works. You see, these sickle cells are hostile environments for the malaria parasite. What happens is because of these cells are abnormally shaped, like crescent moons instead of nice round blood cells, their membranes are stretched and become porous. Therefore, these red blood cells leak the nutrients that the malaria parasites need to survive. The parasites can't get as much out of these sickle cells as normal red blood cells. These faulty cells in somebody who has sickle cell anemia, their body eliminates more quickly these faulty cells, which therefore then also eliminates more quickly the parasite that is attached to them. So somebody with sickle cell anemia actually is better able to fight off malaria than somebody who doesn't have malaria. So some scientists, some who are, believe in the theory of evolution, say that this is a great example of evolution at work, that we can study and see how mutation has helped people. It has been good, and then nature has selected for it. And that's true in a sense, because if, especially in the areas of the world where malaria is more common, sickle cell anemia is more common because nature selected for it there more than other places that didn't have malaria. Because normally, if somebody would have this mutation, this sickle cell anemia mutation, nature would select it away, not select for it, but against it, because it's normally very harmful for people and painful and leads to early death. So nature wouldn't select for it unless it was helpful in staving off or fighting against malaria. And that's where we see sickle cell anemia to be more prominent, is in the areas where there's more malaria. So evolutionists have pointed to this as a great example of, random mutation and nature selecting. However, we can ask the question, is it possible to jump from this example to the conclusion that all the complex machinery of, for example, the human body, like the eye and our human brain, have been developed by this process? And I think that's too much of an extrapolation, and Behe makes the same case. This is too much of an extrapolation. These complex mechanisms like the eye and the human brain can't be explained in this process. Because what's going on here, nothing new is being created. That's Behe's whole point. Nothing new is being built in this process, sickle cell anemia, this mutation. In fact, according to Behe, this is a good example of what mutation and natural selection can't do. It's a good example of what it can do. It can break things and make things not work correctly, but sometimes breaking things can be helpful. So in other words, when an army is invading your territory, sometimes it's useful to burn your own bridges. So breaking things, mutations that harm our bodies and make things worse, can sometimes be useful, and when they are, nature selects for it. And that makes sense. But the key thing is nothing new is being built here. Normally this would never be picked up by nature because normally sickle cell anemia is only harmful. It's only in this unique situation with predominant malaria areas that it can be helpful to break things in this sense. Well, the other example that Behe goes through is HIV and AIDS. And this is even better than malaria and sickle cell anemia because AIDS literally mutates at the evolutionary speed limit. I mean, there's virtually nothing else that goes this fast. We can study multiple billions of generations of the AIDS virus and see how it mutates and how it changes. In fact, here's the number. I'm going to give you a number here on the screen in a minute. This is the number of copies of the virus that have been produced over the last few decades. Not in laboratories or anything, but just through the mutation and this virus reproducing itself. This is how many copies have been produced in the last few decades since AIDS came about. Late 70s, early 80s. It's 10 to the 20th power. So think of all the generations where we've been able to observe over the last few decades and witness mutation and natural selection at work to see what it can actually accomplish. So what has evolution produced in all of these generations in the AIDS virus? Well, it's produced very little. Now the media, in the news, they'll make a big deal about all these mutations in the AIDS virus and how it's developed. It's become resistant to every drug that we throw at it. And that's all true, right? It has mutated and become resistant to every drug that we've tried to produce against the AIDS virus. It quickly evolves in that sense through mutation to become resistant to drugs. However, on a functional biochemical level, it's been a complete stick in the mud. It hasn't produced anything new. Now, its DNA sequence, scientists have studied, its DNA sequence has certainly changed. It's become resistant, as I said, to every drug that we've come up against it. But through that, there's been no significant basic biochemical change to the AIDS virus at all. This drug resistance, that mutation, is just another example of microevolution taking place on a small scale. So here, think about this just for a moment. We have thousands and thousands, trillions and trillions of organisms been reproduced through this process, and very little biochemical significance to show for it at all. We haven't seen, for example, through this process, mutations create any new complex structural information. We haven't seen it produce anything new. It's still the AIDS virus. It hasn't created a new species. It hasn't even created any new mechanisms or any new complex structural information. Now again, those who affirm evolution will always propose scenarios that they imagine, right? They'll propose these just so stories of how possibly macroevolution could have taken place, that enough of these beneficial accidents could accumulate over time to account for the creation of new complex systems. But the thing is, we've just not witnessed that empirically. From empirical observations, we've just never seen that happen. So we can ask, is imagination enough? Is it enough to imagine possibilities, imagine how it could have happened if we can't show it empirically? Imagination is good for making hypotheses, right? I mean, that's how a lot of scientific studies and theories get started, with imagining or coming up with hypotheses, and then we test them. So it's great to use imagination for hypotheses, but it's not good science to make conclusions based on mere imagination, on what could possibly happen. And scientists recognize this. I'm going to give you a quote from Jerry Coyne and Alan Orr. Now these folks, these guys, are evolutionary scientists. They affirm evolution, but they admit and agree that imagination is not enough. Okay? For example, they wrote, "The goal of theory is to determine not just whether a phenomenon is theoretically possible, but whether it is biologically reasonable. That is, whether it occurs with significant frequency under conditions that are likely to occur in nature." This is a quote from Behe. "It's not just that certain biological systems are so complex that we can't imagine how they evolved by Darwinian pathways. Rather, we can show conclusively that direct Darwinian pathways are causally inadequate to bring them about, and that indirect Darwinian pathways, which have always been more difficult to substantiate, are utterly without empirical support." Again, it's this imagination, how it could have possibly happened, but empirically we don't see it taking place. With HIV, malaria, thousands, millions, trillions of generations, and we don't see anything new being produced. Now, as we've gone through, what I think is the strongest argument against evolution, I do want to circle back and say, I understand why evolution makes sense to so many people, because it's partially correct. As we said at the beginning, evolution, at a small scale level, microevolution if you will, does explain a lot. It explains the diversity we see with different beaks on birds, finches. It explains why moths are different colors. It explains why we have so many different types of dogs. It explains why human races are so different, because we've adapted through this microevolutionary process to have different skin colors, different types of hair, eye. All the differences we see are just the result of this microevolutionary process. So I can sympathize with Charles Darwin and even modern day evolutionists when they see this on a small scale basis, want to extrapolate that to a large scale basis as well. But the evidence is just not there. The best empirical evidence we have, for example, like malaria, HIV, we can learn and see that mutation just wreaks havoc. It doesn't build anything new. It's only helpful when it breaks things sometimes, like burning bridges. There's just no way it can account for the mind-boggling systems that we discover in Bacterial Flagellum, not even to mention our bodies, eyes, human mind. So microevolution, the shifting of genes, is a powerful tool of adaptation, but there's just no empirical evidence that it can go beyond that limit to actually create new species. Here's another quote from Michael Behe. He wrote, "The structural elegance of systems such as the cilium, the functional sophistication of the pathways that construct them, and the total lack of serious Darwinian explanations all point insistently to the same conclusion. They are just far past the edge of evolution." He wrote, "From observing the mutations in the battle with malaria and HIV, the conclusion is this: random mutation is not sufficient to account for large-scale evolutionary changes. In other words, known material mechanisms capable of causing genetic modification cannot account for the vast increases in functional information required for macroevolution." Now, if you're interested, here are some of the books that I've referred to. Michael Behe, this is Darwin's Black Box. This has more to do with his irreducible complexity, but the one I focused on tonight is his Edge of Evolution, where he looks at malaria, HIV. And then I've also quoted sometimes from William Dembski, this book, The Design of Life. Now, I've put all this in a paper, and I'm going to publish it on my website soon, convincingproof.org. So if you'd like to see this more in writing, or if it could be useful to you in that sense, check out my website soon. And I'm going to put this out in an article on my website. It'll probably be a two-part thing, but the first part we'll put out there soon, within a week, I hope. Now, I have another discussion question for the group here taking the class live, but those online can pause and maybe think through this themselves. And the question is, let's say I'm wrong. You might remember I mentioned this at the beginning. What if evolution is true? I've tried to make the best case that I know of that evolution is false, and I'm convinced it is, but let's say I'm wrong. Let's say evolution is true. If evolution is true, would that then mean that God doesn't exist? Would that prove that there is no God? So I'll let you discuss that or think about that here for a few minutes. Okay, so the question we're going to tackle first is, let's say I'm wrong. Behe's wrong. Even macroevolution is correct. It's true. That's how we came to be. So if evolution is true, would that mean that God, we'd have to conclude, therefore, that God doesn't exist? Does that prove, if evolution was true, would that prove that there is no God? And I'm going to make the case that it wouldn't. So you might remember this slide from the very beginning. I'm going to make the case now that even if evolution is true, it still doesn't prove that there is no God. Now, I would say, if evolution is true, that it might weaken the design of life argument for God. Okay? But I say might there, because if you think about it, it may not weaken it. If evolution was true, it might actually strengthen the design of life argument for God. I want to give you a quote from Stephen Barr. I didn't use him very much tonight, but last week and the last 2 weeks, for both the first cause argument and the design argument, I leaned on Stephen Barr a lot. He's a physics professor at the University of Delaware, and I want to share a quote from him, and I think he makes a good point here. Stephen Barr wrote, "Paley finds a watch, and he asks how such a thing could have come to be there by chance. Richard Dawkins finds an immense automated factory that blindly constructs watches and feels that he's completely answered Paley's point. But that's absurd. How can a factory that makes watches be less in need of explanation than the watches themselves? Darwinian evolution, far from disproving the necessity of a cosmic designer, may actually point to it. We now have the problem of explaining not merely a butterfly's wing, but a universe, a factory, if you will, that can produce a butterfly's wing." So even if evolution is true, I don't think it even necessarily negates the design of life argument for God. Also, I think we need to consider that evolution does not, nor can it even, explain the origin of life. Remember how evolution is supposed to have worked. It can only begin if there are organisms that are reproducing themselves and reproducing themselves, their offspring aren't exact copies of themselves. There's got to be self-reproducing organisms that have different traits among themselves for natural selection to even start working. But think about that. Where would you get reproducing organisms that produce offspring with different variations? That couldn't have come about from evolution. Evolution can't even get started unless you have that up and going in the first place. So I think you can build a really solid design of life argument from just the origin of reproducing life. And if you think about it, life reproducing itself, organisms reproducing themselves, is one of the most complicated things about life, reproduction. And evolution has no way of explaining that. So I think you can still argue for design just from the origin of self-reproducing life. In fact, I'm going to give you another quote from Stephen Barr about this issue. He wrote that the origin of life problem is made very hard by the fact that the first primitive life form was probably already enormously complicated, partly in response to claims that vestiges of one-celled life had been discovered in Martian rocks from Mars. Biologists have given some thought to the minimum requirements for a self-reproducing one-celled organism, simple life. It appears that it needs to have quite an elaborate structure involving dozens of different proteins, a genetic code containing at least 250 genes, and many tens of thousands of bits of information. Simple life that can reproduce. And evolution just couldn't build that because it needs all that up and going for it to even work. Regardless, though, there are many other good, solid arguments for the existence of God. So let's say, it does weaken the design of life argument. There's still, as we looked at the design of the universe, the fine-tuning argument, which most say is the best, most compelling argument for God. We've got other ones, the first cause argument we've looked at, more that we're going to consider, the moral argument next week, and there's multiple arguments for the existence of God. We're just looking at the big three, but there's others like ontological arguments, so on and so forth. The other thing I want you to keep in mind too, though, is that these two ideas or these two beliefs aren't mutually exclusive. So the belief that there is a God and the belief that evolution is true are not necessarily mutually exclusive. In other words, somebody could, and many people do, believe in both of them. It's not like they're beliefs that can't both be true. No, in fact, both beliefs, both things, propositions can be true at the same time. There could be a God who exists and evolution could be true. Both things could both be true at the same time. They don't cancel one another out. Folks who believe in both of them, there's a name for folks like that. They're called theistic evolutionists. They're theists. They believe that there is a God, but they also believe in macroevolution. They're theistic evolutionists. I think you probably might be more interested in the second question that I put up on that yellow slide, the second discussion question. And that is, would evolution, if it were true, disprove Christianity? Now, we're in the process in this class of making an entire case for Christianity, and we're not done yet. We haven't even started talking about Jesus or the Bible. We've just been making a case for the existence of a supreme being so far in this class. But I would assume a lot of you watching this are Christians who believe that Christianity is true. So maybe we can jump ahead a little bit and ask the question, if evolution were true, would that somehow negate Christianity? In other words, if you came to believe that evolution, macroevolution is true, would you therefore have to reject Christianity? So we could run Christianity through this same process, and I would make the same argument. First, we could say, if evolution is false, then certainly it doesn't prove Christianity is false. That's a no-brainer, right? And the same thing, we could look at the strongest arguments that evolution is false. We've done that tonight already. But I would argue, and this might be a little bit more controversial with some Christians, I would argue that even if evolution is true, this still doesn't prove that Christianity is false. Now I want to take a couple minutes here as we close for me to make that case, okay? Because I think a lot of people that I talk to, especially a lot of young people who have grown up in a Christian home or church, they do have this mentality. I've talked with a lot of young people who go on to study science or go to a university and take science classes, and they become convinced that evolution is true. For whatever reason, I would respectfully disagree with them, but they come to the conclusion that macroevolution is true. And they think, therefore, that they have to reject Christianity. And I try to make a case against evolution, of course, lovingly and respectfully with them. But I also try to help them understand that, look, even if you have accepted evolution as true, that doesn't necessarily mean you have to reject Christianity. And I'll try to make that case now. It's important, as Christians, that we make a distinction between primary Christian beliefs and secondary Christian beliefs. What do I mean by that? Well, there's some primary beliefs that just have to be true. If they were false, Christianity would be proven false. So there's some primary beliefs to basic tenets of Christianity. Things like, God exists, Jesus is God, Jesus died on the cross, Jesus was literally bodily resurrected 3 days after he died, and trusting in Christ reconciles you back to God. You're forgiven, reconciled back to God, and welcomed into heaven for all eternity to be with God through faith in Christ. Those are just, primary beliefs of Christianity. If any of those were proven wrong, then yeah, Christianity would be proven wrong and as a whole should be rejected. However, there's a whole host of secondary beliefs that there's differences and disagreements within the Christian community. And, depending on who's right or wrong, it wouldn't disprove Christianity as a whole, basic or mere Christianity, if you will. Well, what are some of these secondary beliefs? The age of the earth, the age of the universe, if you will. Some Christians believe that the universe is old, 14 plus billion years. Some Christians believe it's very young, just a few thousand years old. Some Christians believe that Jesus is going to set up a literal kingdom on earth someday. Other Christians don't believe that Jesus is going to return and set up a literal kingdom here on earth. It's a disagreement among Christians. Some Christians believe that the Old Testament laws should be followed today. Other Christians say no, the Old Testament laws don't apply to us. So that's a secondary belief that Christians disagree about. There's all sorts of examples of this. You can think of different beliefs about communion or what type of songs should be sung at church. Whatever position ends up being right on these secondary issues, it's not going to disprove Christianity either way. And I would say that macroevolution is one of these issues. There are Christians who believe that macroevolution, and there's Christians like myself who think it's false. But this is a secondary belief, and no matter who is right at the end of the day, neither side or neither position being true would negate Christianity. These primary Christian beliefs would not have to be rejected even if somebody accepts macroevolution, if macroevolution ends up being true. So I want to end here with a few examples of people like this. So Christians who believe in macroevolution. Now, I would respectfully disagree with them, but I think you need to be aware of these folks, just so that you're aware that these folks, or that these two beliefs can be both held in common. You don't have to reject Christianity if you come to believe that evolution is true. For example, Francis Collins, one of the most famous, well-known scientists alive today. He is the one who led the Human Genome Project, which mapped the human genome. He was nominated by President Barack Obama to be the director of the National Institutes of Health. I mean, you can't get much higher in the scientific community than Francis Collins. He's received the Presidential Medal of Freedom and National Medal of Science. He wrote the New York Times bestseller, which I've read, The Language of God, A Scientist Presents Evidence for Belief. And he's one of the founders of BioLogos. It's an organization which advocates and promotes that Christianity can be reconciled with evolution. They came up with this phrase, evolutionary creation. So they affirm Christianity and macroevolution. So you might want to check out BioLogos. You can read more about that organization and their scientific beliefs and their beliefs in Christianity. Another example, there are people who believe in portions of macroevolution. We already said Michael Behe, who's also a Christian, by the way, but he believes in common descent. He rejects, the idea, of course, as we've discussed, that natural selection and random mutation can create, all these new species, but he does affirm that all of the existing species that we have can be traced back to a common ancestor. He just thinks that there's another process that has created the different species from this common ancestor, that God stepped in and specially created and guided the process, that random mutation and natural selection couldn't do it, but God could cause the evolution, if you will, process from a common ancestor. So he affirms common ancestor, Michael Behe, and so does Stephen Barr. So the scientist that I've often quoted. Let me read to you another quote from him. He says, "There's a great deal of evidence, it seems to me to be overwhelming evidence, that evolution happened." Well, what does he mean by that? He means that there's a great deal of evidence pointing to the fact that all life on Earth evolved from a common ancestor. There's also a great deal of evidence that natural selection plays a large role in evolution. What's lacking, though, so he believes in some macroevolution, but not the entire theory. I'm saying that that's a possibility too, as a Christian. What is lacking is sufficient evidence to prove that natural selection by itself is capable of doing the whole job of driving evolution. On top of that, there are discoveries in recent decades that make that job look a lot harder than it once did. Now, I will say this. If evolution is true, let's say tomorrow I become convinced, it becomes proven without a shadow of a doubt tomorrow that macroevolution is in fact true, I will say that it would impact some of our theological positions, okay? So some of these folks who believe in macroevolution, of course it has affected some of their theological positions. In other words, we would have to rethink. If we came to believe tomorrow that evolution was in fact true, we would have to rethink, some of us at least, would have to rethink our interpretation of some of the portions of the Bible. We might conclude then, let's say I was convinced tomorrow that evolution is true, I might have to side more with C.S. Lewis or St. Augustine. One of the ancient church fathers, St. Augustine, I might have to side more with their interpretation of Genesis, for example. They didn't interpret it as literally as some Christians do, as I do. They interpreted the first few chapters of Genesis in more of an allegorical sense. C.S. Lewis, very famous Christian, and St. Augustine, 1,500 years ago, interpreted the first few chapters of Genesis more allegorically instead of literally. So if we became convinced tomorrow that evolution was true, we might have to side more with their interpretation of Genesis. But that changing our interpretation of Genesis is completely different than rejecting all of Christianity as false. Okay? And there's a sense in which, and we'll close with this, just a few minutes here, it's important to recognize that science can sometimes help us to interpret Scripture better. And it would, in that case, if, let's say, for example, hypothetically, evolution was proven to be true tomorrow beyond a shadow of a doubt, then that science would help us interpret Genesis better and help us recognize that C.S. Lewis and St. Augustine actually had a better, more accurate interpretation. And this has actually happened in the course of history, where science has helped us interpret the Bible better. Now I'm going to present here a chart, and I think this will very much conceptually help you. It's helped a lot of people conceptualize this process, because to a lot of people what I'm saying right now is almost anathema, right? It's almost crazy talk that science can actually help us interpret the Bible. A lot of young Christians, unfortunately, have been scared away from science and scientific discovery, thinking that it's evil or anti-biblical in some sense. But let me show you a better way to think about things, all right? I would make the case, and I'm not alone, pretty much all Christian theologians would agree, that God communicates to us in two different ways. Sometimes it's called general revelation and special revelation. He reveals truth to us in two different ways. So one way, general revelation, God communicates to us through nature, His creation, if you will, and He also communicates to us, according to Christianity, through Scripture, and that's direct, special revelation. And there's no conflict between these two things. If Christianity is true, there can't be any conflict between these two things. These two revelations cannot conflict if Christianity is true. I know in this class yet I haven't finished making my case for Christianity, but assuming that I did, and we've come to the conclusion Christianity is true, these two things cannot conflict. The problem is, as finite beings, we have to interpret these things. Both of these things. Both revelations we have to interpret. And we call these interpretations science and theology. In other words, what we call our interpretation of nature, we call that science. That's one way to think of science, is that's our theory or our understanding or our best interpretation of what's going on in nature, right? But the same is true with direct revelation, direct special revelation, Scripture. We have to interpret it, and it's not always easy. It's difficult sometimes to know exactly what God meant or God means through His direct special revelation. Sometimes it's easy, but sometimes it's difficult to interpret. We get it wrong sometimes. I know I have. So there are many times where science and theology have conflicted. But when that happens, let's say again, hypothetically, tomorrow, I become convinced, or everybody becomes convinced that macroevolution is true. It's proven beyond a shadow of a doubt, right? So we've become convinced that evolution is true. Well, that might affect our theology, how we interpret certain verses or certain chapters in Scripture. And in fact, that has happened in history. Scientific discoveries have helped us to have better theology. Scientific discoveries have helped us interpret the Bible more accurately. I'll give you an example of that. So, several centuries ago, Christians and theologians interpreted several verses in the Bible, including many in the book of Psalms, that talked about the earth being firm and stable. Well, they interpreted those verses to mean that the earth doesn't move. But then, as you know, with Galileo and other scientists discovered that no, in fact, the Earth does move. It seems counterintuitive, but the Earth is actually flying around space, flying around the sun. The Earth is not stable and firm in that sense. And it took many in the church a while to humble themselves and to recognize that their interpretation was wrong, their theology was wrong. But you see, science helped them to come eventually to that conclusion. And I think we, as Christians, or theologians, if you will, need to be more humble about our interpretations. We need to recognize that we are finite creatures, we are finite beings, and we interpret things wrong sometimes. And make a distinction between Scripture, which most Christians believe is perfect and infallible and has no mistakes, make a distinction between that and our interpretation of Scripture, which definitely can have mistakes and errors in it. I know mine does and has. And so our science, our interpretation, our understanding of nature can actually help our interpretation of Scripture, our theology, become better. All that to say, even though I reject evolution, I'm open to the evidence. I want to be humble enough to listen to scientists who study this. And it might be, if evolution is proven true to me, that I have to adjust my theology, my interpretation of the first few chapters of Genesis, side more with C.S. Lewis or St. Augustine. But that would be far different than me rejecting Christianity completely. If evolution were proven true to me tomorrow, I would not reject Christianity. I would just change my theology in some areas. So that's my advice to you, those of you who might have become convinced that evolution is true. It doesn't mean you have to give up on Christianity. Of course, would mean that you would, interpret things a bit differently. But we can talk about that and have conversations about that because those are secondary issues within Christianity that we can debate and disagree on. They don't affect our basic primary Christian beliefs, even if macroevolution were true. Well, I'm going to move on to just the class logistics very briefly. Those of you taking this class in Germany, or those of you just watching the lecture online, none of this would pertain to you. But those taking it here this semester, spring of 2021, here in Nebraska, through Midwestern Seminary, Spurgeon College, I want to talk about just our syllabus and what's coming up next. So tonight is February 18th, and we talked about evolution. You had to read chapters 4 and 5 in Frank Turek's book. You had to read chapters 10, 12, and 13 in Thinking About God, and then chapter 8 in Love Your God with All Your Mind. So all those reading summaries, all those chapters are due tonight. 1 paragraph per chapter, no longer than 1 total page. Email that to me tonight by midnight. Following along the class schedule, I gave a lecture on evolution tonight. To get ready for next week, February 25th, only have 3 chapters to read, 1 chapter in each book. Chapter 6 in Turek's book, chapter 11 in Thinking About God, and then go back and read chapter 1 in Moreland's book, Love Your God with All Your Mind. I have to do reading summaries on those, of course, and then my lecture next week, February 25th, will be on the moral argument for God. And that's the one that I specialize in. That's the one that I've done most of my research work in, did my PhD dissertation on. So I'm very excited to cover that material with you next week.